Welcome! I am Teacher M. This tutorial video is focused on definition of limit and how to get the limit by observing its graph and table of values. If you are interested, stay and watch the entire video. In my experience of teaching, there are a number of students who actually confused what limit really is and how it is different from the other concept of mathematics. To understand the limit, let's define limit first. According to Larson, in his brief calculus book, if a function becomes closer to a certain number L as its x approaches c from either side, then the limit of a function as x approaches c is equal to the number L, which is read as the limit of a function as x approaches c. Let's define the important term in this topic, which is the term approach. According to dictionary, it is defined as come near or nearer to someone or something in distance or time. In connection to the definition of limit, this is simply mean that what is a number where the function is getting nearer to, which is the number L, when its x is getting nearer to a certain number c from either side. To visualize and understand it more, let's use this example. Given the function, the quotient of the difference of x cubed and 1 and the difference of x and 1. Let's observe the value of the function when it is evaluated at x is equal to 1. Substitute 1 and we have f of 1 is equal to 1 cubed subtracted to 1 over 1 subtracted to 1. Then simplify the numerator and the denominator. 1 cubed subtracted to 1 is 0 over 1 subtracted to 1 is also 0. Thus, the function is undefined at x is equal to 1. How about if we are asked, what number is the function approaching to when its x value is approaching to 1? Or what's the limit of the function as its x approaches 1? It is important to know the definition of limit. If you're asked to find the limit of the function, you are asked to observe where the function gets closer and closer to when its x gets closer and closer to a certain number. To visualize, let's graph the function. The function is a parabola with a hollow point at x is equal to 1. This signifies that the function is not defined at x is equal to 1. On the left side of 1, observe that when the x value of the function is getting closer to 1 as possible, the function is getting closer to what number? I'll give you 5 seconds to observe the graph. Yes, it is getting closer to 3 as possible. Similarly, observe the right side of 1. When the x value is getting closer to 1 from the right side, the function is getting closer to what number? I'll give you 5 seconds to observe the graph. Yes, the right side is behaving the same way. The function is also getting closer to 3. This means that the limit of the function as its x getting closer to 1 from either side is 3. Or we can read it as the limit of the function as its x approaches to 1 is 3. Note that the illustration does not overlap at exactly x is equal to 1 and f of x is equal to 3. By zooming in, we can clearly see that it's about to approach the numbers. To make it more concrete, let's observe the function using its table of values. We are observing the function when its x is closer as possible to 1, but not exactly at 1. You may choose any number that is less than 1. For this example, I select 0 and continue to select numbers that are closer to 1, which are 0.9, 0.99, and 0.999. These numbers may vary depending on your selection. You may select closer numbers than I used on this example. I will do the same thing on the right side of 1. I selected 2, 1.01, 1.001, and 1.0001. Then, substitute each selected x value to the function. I'll give you 5 seconds to think whether to pause this video and complete the table on your own, then check your answers afterwards, or continue watching the video. When x is 0, the function is. When x is 0.9, the function is 2.71. When x is 0.99, the function is 2.9701. When x is 0.999, the function is 2.9997. On the other side, when x is 2, the function is 7. When x is 1.01, the function is 3.0301. When x is 1.0001, the function is 3.003. And when x is 1.0001, the function is 3.0003. Observe from the left side, when the x value of the function is getting closer to 1, as close as possible, the function is getting closer to what number? Take note, a number that the function is getting closer to. Yes, it is getting closer to 3. On the other side, the function is behaving the same way when its x value is getting closer from the right side. Observe the table of values. The function is getting closer to 3 as its x getting closer to 1 as possible from the right side. Thus, the limit of the function as x approaches to 1 is 3. Another example, given the function, the quotient of the difference of x and 1, and the difference of the root of x and 1. What will be the value of the function at exactly 1? I encourage you to pause this video at this moment and give it a try, then continue to check your answer. Substitute 1, and we have g of 1 is equal to the quotient of the difference of 1 and 1, and the difference of the root of 1 and 1. Simplify numerator. The difference is 0. Simplify the denominator. The difference is also 0. Likewise, this example is not defined when x is 1. How about when its x approaches 1? Let's graph the function. The graph of the function is shifted 1 unit above the origin, and it has a hollow point at x is equal to 1. Observe that when the x value of the function from the left is moving closer to 1, the function is moving closer to what number? I'll give you 5 seconds to observe the graph. By observing the graph, the function is moving closer to 2 as its x is moving closer to 1. On the other side, when the x value is moving closer to 1 from the right side, the function is moving closer to what number? Again, I'll give you 5 seconds to observe the graph. Yes, it is also getting nearer to 2. Thus, the limit of the function as x moves closer to 1 as possible is 2. Or the limit of the function as x approaches 1 is 2. If we observe it at x where the x value is at the nearest point as possible, observe that it looks like that it is exactly at 1. But when we zoom it in, it is as near as possible to the number. Similar behavior can be observed using the table of values. We will do similar process that we did on the previous example. We are tasked to observe the behavior of the function when its x value is moving closer to 1 but not at 1. Select your x values. In this case, I am using similar set of numbers that was used in first example. From left, we have 0, 0.9, 0.99, and 0.999. On the other side, we have 2, 1.01, 1.001, and 1.0001. Then substitute each x value in the function. I'll give you 5 seconds to think whether to pause this video and complete the table on your own, then check your answer afterwards, or continue watching the video. When x is 0, the function is 1. When x is 0.9, the function is 1.9487. When x is 0.99, the function is 1.99950. When x is 0.999, the function is 1.999950. On the right side, when x is 2, the function is 2.4142. When x is 1.01, the function is 2.005. When x is 1.001, the function is 2.0005. And lastly, when x is 1.0001, the function is 2.00005. When x value is getting closer to 1 from the left side, the function is getting closer to what number? And when x value is getting closer to 1 from the right side, the function is getting closer to what number? Pause the video and observe the table of values. When x is approaching 1 from the left, the function is approaching 2. When x is approaching 1 from the right, the function is also approaching 2. Thus, the function is getting closer to 2 when its x value is getting closer to 1 from the either side, or the limit of the function as x approaches 1 is 2. Another interesting function, a piecewise function. H of x is equal to two different function, which is x with the domain of less than or equal to 1 and 1 minus x with the domain greater than 1. Let's see the value of the piecewise function when x is 1. We are going to use the first function, which is h of x is equal to x. Since the condition of x is should be equal to 1, and it is satisfied by the domain of the function. Substitute 1, then the function is equal to 1. What is the limit of the function when x approaches 1? Using its graph, observe that when x is moving closer to 1 from the left side, the function is approaching what number? I'll give 5 seconds to observe the graph. The function is approaching 1 when x is approaching 1. On the other side, when x is moving closer to 1 from the right side, the function is approaching to what number? Again, I'll give you 5 seconds to observe the graph. The function is approaching 0 when x is moving nearer to 1 from the right side. In this example, the function is approaching different numbers from the left and right side. In this case, if a function is approaching different numbers, the limit is not existing. Let's see if you have similar result if you're going to use table of values. Set up your table of values. We are observing the function when x is moving closer to 1. From the left of 1, we have 0, 0.9, 0.99, and 0.999. From the right side, we have 2, 1.01, 1.001, and 1.0001. Substitute each x value to the function. I'll give you 5 seconds to think whether to pause this video and complete the table on your own, then check your answers afterwards, or continue watching the video. Since the value from the left side of 0 is similar to the condition of less than 0, the first function, which is h of x is equal x, satisfied the domain constraint. Thus, use this function. When x is 0, the function is 0. When x is 0.9, the function is 0.9. When x is 0.99, the function is 0.99. When x is 0.999, the function is 0.999. On the right side, since the value from the right side of 0 is similar to the condition of greater than 1, the second function is satisfied the domain constraint. Thus, use h of x is equal to 1 minus x. When x is 2, the function is negative 1. When x is 1.01, the function is negative 0.01. When x is 1.001, the function is negative 0.001. When x is 1.0001, the function is negative 0.0001. By observing the table of values, when x approaches 1 from the left side, the function is approaching 1. And when x approaches 1 from the right side, the function is approaching 0. The function is approaching different numbers. Thus, the limit of the function as x approaches 1 is not existing or does not exist. Last example, we have the function 1 over x squared. Let's evaluate the function at x is equal to 0. Substitute the value of x, then simplify. We have g of 0 is equal to 1 over 0 squared. If we simplify this, The function is not defined when x is 0. What will be the limit of the function when its x value is moving closer to 0? By analyzing its graph, when x approaches 0 from the left side, the function is moving closer to what number? I'll give you 5 seconds to observe the graph. Observe that the function is not approaching a certain number. The function moves to a larger and larger number. This behavior is also observable from the right side. Using table values, we can see this similar behavior. Set the table of values as the x is approaching to 0 from either side. From the left, I used negative 1, negative 0.1, negative 0.01, and negative 0.001. On the other side, I used 1, 0.1, 0.01, and 0.001. Then substitute each x value to the function. I'll give you 5 seconds to think whether to pause this video and complete the table on your own, then check your answers afterwards. Or continue watching the video. When x is negative 1, the function is 1. When x is negative 0.1, the function is 100. When x is negative 0.01, the function is 10,000. When x is negative 0.001, the function is 1 million. On the right side, when x is 1, the function is 1. When x is 0.1, the function is 100. When x is 0.01, the function is 10,000. When x is 0.001, the function is 1 million. If you continue to evaluate it using a closer number from either side, the function is getting larger and larger. The function does not approaching a certain value of x, but it behaves the same way from the either side. Observe that the function is getting larger when its x approaches 0 from the left side and similar to the other side. What will be its limit? The limit of the function as x approaches 0 is positive infinity. Note, infinity is not a number, but it describes an idea that has no end. In this case, the function is endlessly getting larger and larger and larger in the positive side of the number line. That's why the limit from the left and from the right is a positive infinity. There you have it, the definition of limit and how to find the limit by observing its graph and table of values. If you learned on this video, don't forget to hit the like button and subscribe to be updated and notified for other math lessons. See you!